Welcome back to GCSE Physics by SmartPath Tutoring. This video is on investigating springs. You can investigate the link between force and extension practical. Set up the apparatus as shown in the diagram. Make sure you have plenty of extra masses. Then measure the mass of each with a mass balance and calculate its weight, the force applied, using W equals mg. You could do a quick pilot experiment first to check your masses are a good size. Using an identical spring to the one you will be testing, load it with masses one at a time, up to a total of 5. Measure the extension each time you add another mass. Work out the increase in the extension of the spring for each of your masses. If any of them cause a bigger increase than the previous masses, you've gone past the spring's limit of proportionality. If this happens, you'll need to use smaller masses, or else you won't get enough measurements for your graph. Number 1. Measure the natural length of the spring. When no load is applied, with a millimeter ruler clamped to the stand, make sure you take the reading at eye level and add a marker, for example a thin strip of tape, to the bottom of the spring to make the reading more accurate. Number 2. Add a mass to the spring and allow it to come to rest. Record the mass and measure the new length of the spring. The extension is the change in length. Number 3. Repeat this process until you have enough measurements, no fewer than 6. Number 4. Plot a force extension graph of your results. It will only start to curve if you exceed the limit of proportionality, but don't worry if yours doesn't, as long as you've got the straight line bit. When the line of best fit is a straight line, it means that there is a linear relationship between force and extension. They are directly proportional. F equals KE, so the gradient of the straight line is equal to the spring constant. When the line begins to bend, the relationship is now non-linear between force and extension. The spring stretches more for each unit increase in force. You can work out energy stored for linear relationships. As long as a spring is not stretched past its limit of proportionality, the work done in stretching or compressing a spring can be found using the formula below, which is E, elastic potential energy, equals half K, which is spring constant, e to the power of 2, which is extension. For elastic deformation, this formula can be used to calculate the energy stored in a spring's elastic potential energy store. It's also the energy transferred to the spring as it's deformed or transferred by the spring as it returns to its original shape. That's the end of the video. I hope that you all enjoyed it.